So till now we discussed the representation of this vector into the Euclidean space and calculated the norm of the vector by two ways, by applying the Pythagoras theorem, and we also discussed the matrix representation of this vector like this, and calculated the norm by using the matrix method also. So we calculated by using the matrix method by calculating the factors v vector transpose and vector v. This expression is called inner product. Inner product of vector v itself with itself. In general, if I will take two vectors v1 and v2, so how to represent the inner product of these two vectors? It is represented as you can take any vector and make its transpose multiplied by the v2, or v2 you can take its transpose multiplied by v1. These expressions give the inner product of v1 and v2. The inner product has a deep significance. If you will take two arbitrary vectors, that is v1, that is v2, into two different directions, x direction, y direction, if they are perpendicular to each other, the angle between these two vectors is 90 degree. So they are called orthogonal vectors, and the inner product of either one to the other one will be 0. Inner product, if it is 0, it means both the vectors are having 90 degree angle between each other. It means you cannot project this vector onto the v1 and you cannot project the vector v1 onto the v2 and vice versa. If you will take a vector v1, that is vector v2, the angle between these is not 90 degree, then in general inner product may not be equal to 0. It means you can project this vector onto this one and you can project this vector onto this one. But in this case, if the angle between these two arbitrary vectors is 90 degree, one vector you cannot project to the other one. Fine enough. Now we are going to elaborate the discussion more onto the matrix representation of the vector, that was 3 and 4. I will write here the vector 3i plus 4j. It was 3 and 4, and this was the matrix representation. So vector v has the matrix representation 3 and 4. I can ask what will be a question, what will be the matrix representation of the vector I and j. So I can do a little bit mathematical manipulation here. I can decompose the matrix like this: 3 and 0, and that is 0 and 4. This is further I can decompose. 3 I can take common, this will become 1 and 0, plus here I can take 4 common, that will become 0 and 1. So you will see here 3 is multiplied by I, 3 is multiplied by I, it means I is mapped to this matrix. 4 is multiplied by j, 4 is multiplied by j, so j is mapped to this matrix. It means I is mapped to a matrix, that is 1 and 0, and j is mapped to other matrix 0 and 1. Or we can write I will be a matrix 1 and 0 and j will be a matrix 0 and 1. So this is the matrix form of the bases I and j. So this is the matrix form of the vector v. The matrix form of I and j will be this one. And the properties that already we discussed, these two bases has the 90 degree between each other, so the inner product of both the bases will be 0. It means if you will calculate the factor I transpose is one vector, other vector is j, or this is one vector j transpose multiplied by that vector, it both will become 0. So let's calculate this. I transpose, I is given this one, transpose will become I 1 and 0 multiplied by j, j is 0 and 1. If you will calculate this, 1 into 0 plus 0 into 1, that is 0. Answer is 0. Here j transpose means 0 and 1 multiplied by I transpose, that is 1 and 0, that is 0 into 1 plus 1 into 0, that is 0. So it means the inner product of both the vectors are 0. It means they are essentially perpendicular to each other, and you cannot project this basis on this one. You can never project this basis onto the other one. Now we are going to discuss more on the vector v. So I resketch the vector v. That was the point r, this was o, it was the vector v. I could make a perpendicular here at the point p, something like that, and then we sketched the vector I along the x-axis, that is I. We sketched the vector j along the y-axis, that is vector j. Angle between these two 90 degree. And if somebody can ask what is the unit vector along the x-axis, the answer is I. What is the unit vector along the y-axis? That is the answer is j. Somebody can ask what is the unit vector along the vector v. So generally it is represented by the v cap. I take this point s. So v cap is nothing but the vector os, which is a unit vector along the vector v. Now can we calculate this vector? What is the form of this vector? It is easy to calculate a unit vector. I can take the vector v. I can divide this vector by its length, the norm of this vector. So the vector v is given by 3i plus 4j, as we already have taken. The norm of the vector v already calculated 5. I can rearrange the terms, that is 3 by 5i plus 4 by 5j. So this will be the form of the unit vector along the vector v, along the vector v. So can I check that is really v cap a unit vector? So if it is a unit vector, it means this condition, norm of the v, must be equal to 1. So we can easily calculate by looking at this vector form, the norm of this vector by using the Pythagoras theorem. Square root of this component square 3 by 5 square plus this component square 4 by 5 square, it means it will come square root of 9 by 25 plus 16 by 25, and that is being square root of 25 by 25, that is 1. Yes, the norm of the vector v cap is equal to 1, and hence v cap is a unit vector along the vector v. So in this video lecture I have given you the ample of information about the vector v, how we can represent this into the Euclidean space. And once you are writing the mathematical expression of the vector v, like 3i plus 4j, so what are I and j? I and j are the orthonormal bases which are perpendicular to each other. Also they have the unit length, or you can say I is a unit vector along the x-axis, y is a unit vector along the x-axis, I is like this, y is along the y-axis, angle between these two 90 degree, and the system of these two unit vector forms the basis of the vector v, over which the vector v is formed. We also discussed the matrix representation of the vector v and how to calculate the inner product and the norm of the vector v by using two ways, either by using the Pythagoras theorem into the Euclidean space, or either by using the matrix form. And further I also discussed how to find out the unit vector along the vector v, and I also tested that the unit vector which I calculated exactly the unit vector, because it has the norm 1. So this basic mathematics of high school is quite useful in developing the Dirac-Breuil algebra, essential part of the quantum computation, that I will discuss into next video. Thank you.